Section 12.5, we're going to be adding and subtracting polynomials. Polynomials are just sums of algebraic terms. We've dealt with them before. So to add polynomials, we're going to combine like terms. That means they have the same variable or the same letters raised to the same power. So they're going to have the same letters and the same exponents. So if we want to add this polynomial to this polynomial, we have to look for like terms. And probably the easiest way to work this is to set this up with one like term above another like term. That's, I think, the easiest way. So we're adding 5x squared. So I'm looking over here. Here's an x squared term. So we're going to add 5x squared and 2x. Here's a 2x. This is negative 2x. And now we're ready to combine the top terms with this row that we just moved over underneath it. So we don't have anything to add to 4x cubed, so it stays the same. But when we get to the x squared, we have 6 negative, 5 positive. So we have one more negative. So this is negative 1x squared or negative x squared. When we get to the x's, we have 2 positive, 2 negative. So they cancel each other out. That makes 0. And then we have plus 7. This next one, we have this polynomial added to this one. So we're going to line up. We're going to line up the like terms, the ones that have the same variables raised to the same power. So we have an x cubed, and here's an x cubed, so negative 2x cubed. Here's an x, it's just 1. And then we have plus 3, which goes in the column with a constant. So we have 2 positive, 2 negative, they make 0, so those cancel out. When we get to the x's, we have 5 positive plus another 1 positive, so this would be 6x. Then when we get to the constants, we have 10 negatives, 3 positives, so we have, what, 7 more negatives? So here's our answer. And this next box just tells you that they can be added vertically, which is what we did up here. If we line up the terms underneath each other, if we line up the like terms, those that have the same variables or same letters raised to the same power. So here we have one more, and we'll line these up. We have 6x squared, so it's going to go in the, y squared. It's going to go in the y squared column. And then we have a plus 1. So we have 7y cubed. And we have 2 negative, 6 positive. It looks like 4 more positive y squares. And then we have 7 plus 8, which would, 7 plus 1, which would be 8. So here's our answer. It's pretty simple. When we get to subtraction, we're going to remember we're going to have positive and negative coefficients. So we're going to use the same technique we did when we just added positive and negative integers. In other words, we're going to change the sign of each of the terms of the polynomial being subtracted. That's the second one. And then we're going to add. Okay? So really what we're doing is adding the opposite of this second one. So when I look at this subtraction problem, I have this minus this. The second polynomial, we're going to end up adding it once we change the signs of each of the terms. So instead of a positive 2x, we have a negative 2x. Instead of a negative 11, we have a positive 11. So I'm just going to write that underneath here, negative 2x plus 11. And now we'll add the x's. We've got 5 positive, 2 negative, so I have 3 more positive. We have 3 negatives, 11 positive, so we have, what, 8 more positive. So here's our answer. And then again, we have this polynomial minus this one. So we're going to instead of subtracting that, we're going to add the opposite of each one of these. So instead of a positive 2x cubed, we're going to have negative 2x cubed. Instead of a negative x squared, we're going to have a positive x squared. Instead of a positive 1, we're going to have a negative 1. Now I'm just going to write those underneath the first polynomial. Plus x squared minus, whoops. We don't have any x's. This is just a 1, so it's going to have to go in its own column. This is a minus 1. As you can see up here. We have to be sure we have these lined up in the column so the like terms are being combined. So, positive 2x cubed and a negative 2x cubed cancels out. We have 9x squared plus 1. 9 plus 1 would be 10x squared. We have negative 6x, and we have a negative 1. So this is our answer. The last one is a little bit tricky because we have the word from, and we know that to be the reverse word. So if we're subtracting, this is the top one, and this one is the bottom one. So it's this one that we have to change the signs of. We're going to add the opposite of this one. So instead of positive 5y squared, it's going to be negative 5y squared. Instead of a positive 2y, it's going to be a negative 2y. And instead of a negative 6, it's going to be a positive 6. And I'm just going to put this underneath it. Since that's where I have room, here's the y squared, here's the 2y, and here's the constant. So, because of the from, this is really this first one, this is really the second one, and so this is the one that gets the sign changes. And I've just written it underneath because I didn't have much room on top. So we have 5 negative, 3 negative would be 8 negative y squared. We have 2 negative and 2 negative y, which would be negative 4y. And we have 6 plus 1, which would be a positive 7. So you have to watch for this. If it just has a negative sign, then it's the second polynomial. We have a couple more on the next page. And these are polynomials that have several variables. Like this first one has x's and it has y's. So we have to be careful how we line these up. So we are adding, so we don't need to change any signs. We're just going to bring it underneath. So negative 2x squared goes under the 3x squared plus 8xy goes under the negative 6xy, and then we have negative 1y squared. Now we're ready to add. This is an addition problem. So we have 3 positive, 2 negative, so we have 1 more positive. We have 6 negative, 8 positive, so we have 2 more positive xy's. We have 5 positive, 1 negative, so we have 4 more positive y squared. So here's our answer. Okay, this next one is kind of weird because there's a little typing error, but we're just going to work it like it's written. It is a subtraction problem, so instead of subtracting this, we're going to add the opposite. So we're going to change the signs of every term, all 4 terms. So instead of positive 5b squared, it's going to be negative 5b squared. Instead of a positive 2ab, it will be a negative 2ab. Instead of a negative 3, it's going to be plus 3. Instead of a negative 9b squared, it will be a positive 9b squared. Okay, now I'm going to line these up. I'm starting with a b squared, and I don't see one, so I'm going to have to make its own column. It's a negative 5b squared. Negative 2ab is going to go in this column. plus 3, we don't have that either, so I'm going to make a column for it. And now we have a positive 9b squared. This is where there's a typing error. So it's another b squared, so I'm putting it with this other b squared. And now I'm ready to add all of this and all of this. So we have a squared, b squared, and then when we get to the AB, we've got 6 positive, 2 negative, so we have 4 more positives. We don't have any other ABs, but when we get to the b squares, we had 2 of them in this same polynomial, which is an error. So we have a 9 positive, 5 negative, so we have 4 more positives, and then we just have plus 3. So here's our answer. You just have to be careful that you're lining up the like terms, those with the same letters, those raised to the same power. And if you're subtracting, then you have to change the signs of all the second number, or the second polynomial, and then add them together. Just like we did when we had, 4 minus 9. Instead of subtracting a positive, we added the opposite, which would have been a negative 9. So we actually have 5 more negatives. So you would probably know if you had 4 and you needed 9, you would be missing 5. Okay.